Okay, this video reviews polynomials and special products. Now, I already have some stuff written down here. First off, this polynomial here, general form is an x to the n plus an minus 1 x to the n minus 1. We keep going, and we have a1 x plus a0. And then these an's can be any real number. N can only be positive integers. And then the highest value of n is called the degree of the polynomial. So as a quick example here, if we look at, for instance, x cubed minus 3x plus 1, this is a polynomial. All of the terms have integer exponents. Now, we don't have an x squared term, but that's fine. You don't need to. Just because we have x cubed doesn't mean you have to have x squared or anything else, quite frankly. But what we can see here real quickly is that the degree of this polynomial is 3. Alright, so that's all well and good, but let's get down to some of the nitty-gritty arithmetic with polynomials. Again, some of the things you're probably familiar with is adding and subtracting polynomials, so let's just do a quick example here. Let's do two quick examples. So let's look at 6x plus 5 plus 3x minus 2. Now we're supposed to simplify this. We of course hopefully remember that all we do is combine like terms. Now this next step I'm going to write down isn't necessary to do it, but it's just to refresh you. What you do is you group like terms together. So you'd have 6x plus 3x, and then you have plus 5 minus 2. And so 6x plus 3x of course is 9x, and then 5 minus 2 is 3, so I'd have plus 3. Now, that's relatively straightforward. Most people don't have too much difficulty with that. The one that sometimes people struggle with, and I think it's not because they don't understand what to do, I think it's because they're being careless or not being careful on the problem. So let's look at it. 2x squared plus 1 minus the quantity x squared minus 2x plus 1. Now, I go ahead and think of just doing the distributive property first before I try and combine terms together. And if you think about what's out in front here, again, I mean, we wouldn't write it, but there's a 1 out in front there, 1 times. And then this one, though, we will think about it because it's minus, but it would be minus 1 times. So I'm going to go ahead and write, well, 1 times 2x squared, that's just 2x squared. 1 times 1, which is just 1. But now I have a minus, and that's pretty big deal because the minus is, of course, going to change the sign of things. So minus 1 times x squared minus x squared, minus 1 times negative 2x, plus 2x, minus 1 times 1, which is minus 1. Now we just combine like terms, so sometimes people will cross them off as they're combining them. For instance, they'll say, I'm going to do 2x squared minus x squared, which of course is just x squared. So we'd have x squared. And then, okay, let's look for all the x's, if there are any. There's nothing there, but I have 2x. Okay, so this would be x squared plus 2x, and then look at all the numbers. So I have 1 minus 1, which of course is 0, and we wouldn't write plus 0 down. So we get x squared plus 2x. I said hopefully that's pretty straightforward. The next thing we'll look at here, we're not going to do any more adding or subtracting. Let's just go remind ourselves of multiplying. We're first going to go ahead and just simply do a fairly straightforward distributive property. So multiply, and the one we're going to do here is just y squared times 4y squared plus 2y minus 3. Now I will write an additional step here, which is not necessary to do, but I do like to show it on the first example. Of course, the idea here is we're taking this y squared and we're multiplying it in to everything here. And so when we do that, we of course would get 4y squared times y squared plus 2y times y squared minus 3 times y squared. And then we just simplify this, which is said this middle step right here that I wrote, that step, I'd be okay if you didn't write that down. 4y squared times y squared, of course, is 4y to the 4th, plus y times y squared would be y cubed, minus 3y squared. That would be our final answer. Okay, now let's review how we do some multiplication here. Let's just go ahead and right away just review FOIL, which you're probably all familiar with. FOIL, of course, standing for first, outside, inside, last. So let's look at one real quick example here. So if we have x plus 1 times, let's do 2x minus 3. Well, the first would give me x times 2x, which would be 2x squared. The outside would be negative 3 times x, which would be minus 3x. Inside, 1 times 2x plus 2x. And then the last is 1 times negative 3, which is minus 3. And so this would simplify to 2x squared minus x minus 3. And that would be our simplified expression. Now, when you're dealing with FOIL here, you don't have to simply just have it be nice x plus 1. We could have something like 3x squared minus 5 times x plus 10. And we still would FOIL this out, we just might not be able to simplify as much. So if I FOIL this out, I have 3x squared times x, which of course is 3x cubed, and then the outside would be 10 times 3x squared, so plus 30x squared. The inside is minus 5 times x, minus 5x. And then the last is negative 5 times 10, which is minus 50. And then I should say, okay, now I need to simplify, but if I look, there's nothing that I can combine together, so that's my final answer. Okay, to wrap the review up here of polynomials and special products, let's talk about some of the special products. Now, in one of the other previous videos, we already talked about one of them, and this was, we'll go ahead and just look at it again, a minus b times a plus b. Now, you can FOIL this out to verify this is what you get, but the special product is just a squared minus b squared. So let's look at one example here. So if we have 3x minus 4 times 3x plus 4, what this would multiply to, this would simply multiply to 3x quantity squared. That's important. It's not 3x squared, it's the quantity 3x squared minus the quantity 4 squared. So if I do that, then 3 squared, of course, is 9. So this would be 9x squared minus 16. Two of the other special products here would be if you have a plus b quantity squared. Now again, you could FOIL this out, but the special product is a squared plus 2ab plus b squared. So let's look at an example here. Let's look at x plus 3 quantity squared. And we'll go ahead and do this two ways. We'll use the formula first. So the formula says that this would be quantity x squared plus 2 times x times 3 plus quantity 3 squared. And so that would simply be x squared plus 6x plus 9. Now, another way you could do this would just be simply writing x plus 3 quantity squared as x plus 3 times x plus 3. And if you do that, you could just FOIL x plus 3 times x plus 3 out, and FOILing it out, you'd have x squared plus 3x plus 3x plus 9, which then of course simplifies to x squared plus 6x plus 9, which of course is the exact same answer. One final special product, and you might be able to guess it, or some of you might know what one is going to be, and it is the quantity, instead of a plus b squared, it's going to be the quantity of a minus b squared. And this is almost the same. The only difference is I have a squared minus 2ab plus b squared. And again, you can verify this by just doing FOIL. So let's look at an example. Let's look at 3x minus 2 quantity squared. And so this would be equal to quantity 3x squared minus 2 times 3x times 2 plus quantity 2 squared. Then if we simplify this out, we would get 9x squared minus 2 times 3 is 6, times 2 is 12, 12x plus 4.